Hello everyone, welcome to today's lecture on ultrasound therapy. I am Dr. Rita Arya, Assistant Professor, Tagore University, Bhopal. Physiotherapy plays a crucial role in rehabilitation, and ultrasound therapy emerges as a non-invasive technique to enhance recovery. Ultrasound waves penetrate tissues, creating thermal and non-thermal effects. Let's understand the foundational principles behind this therapy. So let's get started. Ultrasound energy is applied to bring physiological changes for therapeutic purpose. Ultrasound is a non-ionizing radiation which is non-audible and acoustic radiation with a high frequency of 0.8 to 1.5 megahertz and wavelength of 0.2 nanometer. In velocity at which the waves travels through the medium, the velocity of ultrasound is approximately 350 milliseconds in air, and it can travel more rapidly in a denser medium. It is used to produce thermal and mechanical effect in the tissues. This energy transmit through transducer, or we can say treatment head, which converts electrical energy into mechanical energy under the effect of piezoelectric crystals like lead, zinconate, titanate crystals. Crystals vibrates, and when it in contact with tissues provides a form of micro massage. Now its principle of production means how it produces. It is not possible to produce ultrasound by mechanical means. So the ultrasound is produced by the application of the rapidly alternating current by piezoelectric crystals. In this, piezo means pressure. Application of pressure, compression and rarefaction or deformation of the crystals produces electrical charges in the crystals, as you can see in the picture, and the mechanical energy is converted into electrical energy. There is another effect called the reverse piezoelectric effect. Application of electricity across the crystal produces oscillation or deformation or pressure changes in the crystals. So, ultrasound point of view, reverse piezoelectric effect is the basic principle which is used in the production of ultrasound. Now move towards the construction of ultrasound. The ultrasound generator consists of oscillator circuit, controlling circuit, resistance circuit, coaxial cable or transducer. Transducer consists of link electrode, quartz crystals, metal front plate, and oscillator circuit produces high frequency alternating current. Here resistance circuit controls the amplitude of the ultrasound waves, and coaxial cable which transfer the high frequency current from the generator to the crystal. Crystal act as a source of the ultrasound waves. Now we will discuss how sonic waves absorbs. Ultrasound will increase the motion of molecules, causing more molecular vibrations and molecular collisions, resulting in heat, and kinetic energy is converted into thermal energy. As it passes through the tissues, the energy will decrease with distance from the source, so that the remaining energy will become smaller and smaller in percentage of the initial intensity. Now we have a slide with modes of ultrasound. Here we have two modes of ultrasound. First is continuous mode. It means ultrasonic energy is constantly produced and can produce thermal effect based on output intensity and treatment duration. And second is pulse mode. Ultrasound output is regularly interrupted, produces non-thermal effects. Next is effect of ultrasound therapy. We will discuss its effect. First is thermal effect, the amount of sonic energy which is converted into thermal energy proportional to the intensity of the ultrasound. If the heat is not dissipated by the normal physiological means, a local rise in temperature occurs and thermal effects will result. Then non-thermal effect is achieved by using low intensities or by pulse output. As you can see in here picture are some other physiological effect also. Now we will understand the non-thermal effect in this slide. First is cavitation. It is the formation of tiny gas bubbles in the tissues as a result of ultrasound. These bubbles are generally a micron, it is about 10 to 6 meter in diameter. They can grow much larger under some circumstances. There are two types of cavitation: stable cavitation and unstable cavitation. Stable cavitation occurs when bubbles oscillate to and fro within the ultrasound pressure waves but remains intact. Transient cavitation occurs when volume of the bubble changes rapidly and collapses. Unstable cavitation causes high pressure and temperature changes and results in gross damage to tissues. Pulsed ultrasound reduces the risk of damage to cavitation. There are some other effects also, and they are like acoustic streaming, means steady circulation flow due to ultrasound application. Due to cavitation, there is a local unidirectional fluid movement around the vibrating bubble. Next is micro streaming. When very small fluid movements occurs around the cell, it is called micro streaming. Micro massage, then the waves of compression and rarefaction may produce a form of micro massage. It used to reduce edema and to break adhesions. Now moving to next slide, and it is about therapeutic uses. Ultrasound is often used after soft tissue injuries as the mechanical effect helps to remove exudates and reduce the danger of adhesion formation. Heat produced by ultrasound in large diameter nerve fiber may reduce pain through gate mechanism. It also accelerated protein synthesis. Stimulation stimulates the rate of repair of damaged tissues. Now last is indication of this therapy. There are many indications in which we can apply or ultrasound therapy, and we can check in this slide. Here in conclusion, ultrasound therapy stands as a valuable asset in physiotherapy. Summarize the key takeaways and its significance in promoting healing. So thank you for watching.